Okay. So, this is a trivial one, right. Okay. Now, this is also a trivial problem. I think you can always again able to answer this one. Now, it says that f r to r defined by this function. So, f x equal to x square if x is less than 0 and 2 x. Yes.
Answer of the previous problem.
Oh, you have given that answer, right? This all of have given that correct one. So, this and this. So, this is we ruled out, right, by this one, and also here we rule out this one. So, many of you have given that right answer of the previous this problem. Okay. So, again we have this kind of problem, suppose. So, some problems will be very conceptual and some problem will be very trivial. So, again this is one of the trivial kind of problem. So, you have this function. So, f x equal to x square when x is less than 0 and x 2x plus x square if x is bigger than 0. Now, you have these options. So, f double dash x equal to f double dash 0 does not exist, f dash 0 does not exist, and f dash x exists for all x not equal to 0. Now, again see, first of all, if you just look at this side A, so for someone can do a mistake, right, that f double a, because if you just we should take some, say this bigger equal to that, because if we just derivative the first one x square, we will have again 2, right, and if we derivative this one, then again it will be 2, right. So, from this actually we will say that the second order derivative exists when x is less than 0 or greater than 0. Now, what about 0? Now, you can just find at 0 that you can just easily check that f dash 0 does not exist, because that left hand derivative at f 0 will be your, or you can just write 0, right, and right hand derivative of at f 0 that will be 2, right. So, that does not exist. Now, since the derivative of the function at 0 that does not exist, so this will not exist and this will not exist, right, and you can easily verify this one. Oh, sorry, this does not exist, right? Good. So, that is does not exist. Fine. Okay. No, it is fine. It is B, C, D, because f dash 0 this does not exist, f double dash 0 also does not exist, and also f dash x exists for x not equal to 0, right. Now, this is also a trivial one. Okay. Now, this is the another one. Now, again for the differentiability, now can you give a quick answer of this one? This is also simple. No, just give the answer. Okay, someone is given the right answer. Don't see the other answer. Okay. Fine. Now, the problem is, see, someone has written it is A, include A, B, C. As I told you, when you are including that x equal to 5, just remember that when we talk about that sin x and cos x graph, right, we take, okay, just wait. When we take mod of cos x, right, and we have this kind of function, right, and this problem, that these points was where cos x is 0, not the x is 0, where cos x is 0, right. Now, if you take x equal to 5, then the value of cos will be just 1, right. Then the left hand derivative and right hand derivative, sorry, yeah, so left hand derivative and right hand derivative, or you can say that if you take, yeah, the both will be the same, because that mod will not affect here because of cos, right. So, this will not be the case, but again when we have sin x, now this will be the problem. Now, again these are the problems where sin x is 0. Now, we know that sin x is 0 when x equal to 0, right. So, therefore, this will be a problem here. So, when mod of x minus 3 is 0. So, sin x is 0 is equivalent to saying that mod of x minus 3 equal to 0, right, and which is same as x equal to 3. So, f is not differentiable here. Oh, I am again right. So, f is not differentiable at x equal to 3, right. Fine. Now, what about this one minus 10? Now, it is given that x plus 10 power 3. Now, you have mod x power 3 actually. Now, we know that mod x power 3 is differentiable, right. Can you find? So, can you tell me what is the derivative of mod x power 3? Yes. If you have f x equal to mod x power 3, then what will be the f dash x? Can you tell me that?
So, derivative will be 3x square mod x, 3x mod x.
Exactly. So, f dash x will be 3x mod x.
Mod x.
Right. So, actually it is the derivative exists at 0 as well. Okay. So, there will be not a problem this one. So, f will be differentiable. But again, whenever you have this one, you have to write this is as mod x whole square, this is just x square, right, plus 8 mod x plus 16 minus of this one, right. Now, again this will be a problem mod x, right. So, x equal to 0 we have a problem. So, this function is not differentiable at x equal to 0 because of this. Okay. So, only at x equal to 3 and x equal to 0 the function will not be differentiable. Okay. Now, I move to the next problem.
Sir, can you explain it again, please?
Yeah, of course. So, first of all, last time I told you that whenever you have a sin x graph or cos x graph, anything you have this kind of graph, that graph is this, right, in this way. Now, if you take, so there will be somewhere pi by 2, 3 pi by 2 kind of this, right. Now, when you have mod of sin x, then that will be this way, right. So, this point will be the reflection, there will be some reflection here. So, that means f is not differentiable at these points, okay. And which points are these? When that sin x equal to 0, and similarly when cos x equal to 0. Now, sin x equal to 0, it is equivalent to saying that x equal to 0, and it is equivalent to saying that x equal to some that 2n plus 1 by 2 pi that no sorry 2n plus 1 pi by 2. So, this one, right. So, anyway, we do not need here in this our problem. So, we are talking about at 0 point only. So, when this term is 0, then it will not affect us for the differentiability. But when this term is 0, then it will affect us, right? Then we will have some reflection. Therefore, at x equal to 3 we have problem. Now, similarly, we know that mod x cube, that is differentiable function, and this is the derivative. You can calculate that. So, there is not a problem at x equal to 3, at x equal to minus 10, but again we can write this one as a this one. Now, this is x square, so we do not have any problem, but this is 8 mod x. Now, we know that mod x is not differentiable, right? So, therefore, we have a problem here. Okay? So, at x equal to 3 it is not differentiable, and at x equal to 0 this is not differentiable. Okay? Now, we have this problem. Now, this problem is a conceptual problem. Okay? This one I like this one. So, first of all, it says that f be a twice differentiable function on R, and given that f double dash x bigger than 0, okay, then we have these options. Now, can you quickly give the answer of this one? So, this is a conceptual one. For this problem, so it says that f has exactly 2 roots. A says f x equal to 0 has exactly 2 solution, means it says f has exactly 2 roots, and B says f x has a positive root if f dash 0 equal to 0 and f dash 0, oops, I missed something, if f 0 equal to 0 and f dash 0 equal to 0. Is it?
Option A is false.
Just a minute. Anyway, so for the timing, just assume that one. But I think I missed something here, or right. It is f 0 equal to 0 and f dash 0 equal to 0. Fine. And for C, it is again, it has no positive solution, there is no positive root. It has, okay, B says it has a positive root, and C says it has no positive root if f 0 equal to 0 and f dash 0 greater than 0, and D says it has no positive root if f 0 equal to 0 and f dash 0 is less than 0. Okay. So, first of all, if you know the differentiability, then what do you mean by this one? That it is says that it is twice differentiable function, and it is saying that f double dash x is bigger than 0. So, what does it mean that f double dash x is bigger than 0?
Sorry.
It is a convex function, sir.
Exactly, good. Okay, just a minute, I have to remove that. Okay, fine. So, it is a convex function, right? Now, this says f is convex. So, after this problem I shall talk about the convexity. Okay. Now, since f is convex, now first of all this one f x equal to 0 has exactly 2 solutions. It is no, right? Now, if you have suppose this one and it is given that f is convex, does it mean that f has a solution, 2 solution? No, it is given that f 0 equal to 0, right? So, we can take this one, that is just f x equal to x square. F x equal to just take x square. Okay? Then f 0 equal to 0, it is a convex, right? But it has only one solution, right? So, this will not be the answer. Now, again the second one says if f 0 equal to 0 and f dash 0 is also equal to 0, then f has a positive solution. So it says actually if the value of function at 0 is 0 and if the this one, that is if the tangent is parallel to 0, then it has a positive solution. Again the same concept will work, right. So if we take f x equal to x square, then this is the tangent, right. So here f 0 equal to 0 and f dash 0 is also 0, but f has no positive solution, right. So again it will not be the answer, right. Fine. Now the second one says f x has no positive solution if f 0 equal to 0 and f dash 0 bigger than 0. Now what does it mean? That's mean, see, remember that f is a convex function, okay. Now f 0 equal to 0, that is at 0 the value of the function is 0, okay, and also f is increasing at 0. That's mean the slope will be the upward, okay. So that's mean you must have a function which is 0 at 0 and this is the slope. The slope will be something like right of this, and since the function is a, see, this should be the f dash x kind of thing, okay. Now since the function is convex, so we must have this kind of function, some this kind of function, since it is convex, and this is the tangent. Did you get this point?
Yes, sir.
So
it will have only one solution, right?
no, it says that if has no positive solution. It can have another solution, negative one. It can be kind of this one, right. Okay. Now it says it has no positive solution because it is a convex one and that is a tangent, right. So this is the right one. Now what about the D? Now again it says it has no positive solution if f 0 equal to 0 and f dash 0 is less than 0. So that's mean that tangent will be so if the value of the function will be this one and the tangent will be something kind of this, the negative tangent. Now what will be the answer?
D is false.
Right. So it can have a positive solution because we can take this kind of curve, right. So which is convex, but it will have another root, another positive solution. Okay. Okay, someone says please explain one more time option C. See, what is that mean? It says that the function is, first of all you have to remember that the function is convex, okay. Convex means I will explain that what does it mean. That means it is kind of this, okay. I will give the proper definition. And also it says that the tangent is positive at 0. Tangent is positive means so we have this kind of tangent at 0, okay. So now since the function is your convex, so therefore you should have this kind of function.
Sir, why this tangent passing through 0, 0, the origin, sir?
No. It is given na f dash 0 is bigger than 0. F dash 0 means we are talking about a tangent at x equal to 0. Okay, you did not get, you should have that passing through 0, right? We are talking about at the point 0. That's mean that according our definition, the tangent line should passing through that point, right?
Okay, sir.
Right? We are talking about tangent at 0. Okay. Now I can just talk about little bit of convexity, because that is a very interesting concept. Just give the proper definition of convex, because you may face few problems from this one. So first of all, a function is said to be convex if you have this one. So f of tx1, or you can say tx plus 1 minus t y, that is less than equal to t of f of x plus 1 minus t of f of y. Okay? And for all x y belongs to the domain D and t belongs to that closed interval 0 1. Okay? Now this is the definition of convex. Note that you have less than equal to. Now similarly you have, so by you can define concave as well. Instead of less than equal to, you have greater equal to. Okay? That is a similar concept of concave. Now this is a convex. Now there is another term called strictly convex. Now again, a function is said to be strictly convex if f of the tx plus 1 minus ty is strictly less than t of f of x plus 1 minus t f of y. Okay? So we are not taking that equal to sign. So it will be strictly. Okay? Now this is called strictly convex. Now there is another term called strongly convex. Now, okay, so I will define that later, because it is for that in this way it will be little bit difficult to define. Anyway, okay. Now you have to remember few facts. So first of all, if f is twice differentiable, remember that twice differentiable, then you have few results. So you have to remember this. Yes, I shall provide this one to the WhatsApp group. So first of all, you have to remember that f is convex if and only if f double dash x bigger equal to 0. Okay, for all x. Remember that it is if and only if criteria. So you may face many problems during your exam when it is involving this statement. Okay, so there are actually. Now second statement is f is strictly convex Now you have to just remember here you have only if condition. It is not the if and only if. Okay? F double dash x is strictly bigger than 0 for all x. It is not the if and only criteria, because f x equal to x to the power 4, that is strictly convex. But f double dash 0 equal to 0. Okay? And another one, now we can define that strongly convex. So, f is strongly convex. So, if and only if f dash x, f double dash x bigger equal to m, and that is bigger than 0 for all x. Okay. So, you have to just better to remember this one, and since it is a if and only criteria, so you can take this one as a strongly convex. So, if you need to find, if you need to check a function is strongly convex or not, generally you will be given that twice differentiable function, because all the functions are actually smooth in our case. Okay? And then f double dash x bigger equal to m bigger than 0. Okay? So, this is the definition. Now, there are few common mistakes which you should not do. So, first one mistake is f x equal to mod x, this is convex, but not differentiable at 0. Now, you can ask that, okay, we know that if function is twice differentiable, then it is convex if and only if it is bigger equal to that, right. Now, this is an example of a convex function, but this is not differentiability. That means we cannot take this as a definition, okay, because there are functions which is not differentiable, but convex. Now, another one that believe is that f x equal to e to the power x is strictly convex in R, but it looks like it is strongly convex, but it is not. Strongly convex. It is not strongly convex. So, this is a common mistake actually, because f double dash x, it is again e to the power x, and it is tends to 0 as x tends to minus infinity, right. So, we cannot find any m. Okay. Now, another one, f x equal to x cube is convex on 0 infinity and concave on minus infinity comma 0. Okay. And there is another common mistake, people generally believe that convex and monotone increasing both are almost same, but they are not same. So, convex does not imply monotone increasing, and monotone increasing does not imply convex. So, during your exam you can face this kind of question, that you have a convex, then it should be monotone, then monotone increasing, then you have to say that no. Okay. So, another common mistake is convex, that is convexity does not imply monotone increasing. So, you can give example, you can take f x equal to, you can take x square, even you can take f x equal to minus x. So, this is another common mistake. So, if you take f x equal to minus x, this is also convex, okay, but sometimes it looks like this is not convex. So, if you take f x equal to minus x, this is also convex, but this is not monotone increasing. Okay. And similarly, monotone increasing does not imply convex. So, for an example, you can take f x equal to root x or log x in or on 0 infinity interval. So, on 0 infinity interval you can define root x and log x. So, they are not convex function, but they are monotone increasing. Now, another one is if you take f x equal to 1 by x square, then this is convex on 0 infinity as well as it is convex on minus infinity comma 0, but not convex on minus infinity comma infinity whatever you define at 0. So, this function is not defined at 0, right. So, whatever value you define at 0, but it will not be convex, but it is convex on these two intervals. And finally, another one is f x equal to, if you take 1 by x, then it is convex on 0 infinity and concave on minus infinity 0. So, these are just result, better to remember this one. So, if you do not remember, then also it is fine, because you will have lots of pressure, but try to remember as much as possible. Okay, there are a few questions. It says f double dash 0 imply f is strictly convex. Is it true or false? Yes, it is. See, it is not if and only if condition, but if f double dash x bigger than 0, then f is strictly convex, but it is not true otherwise. That means f is strictly convex does not mean that f double dash x bigger than 0. For an example, f x equal to x to the power 4. Another one, please give a geometrical structure of strictly and strongly convex, how it looks like and defined. Okay. That generally that main important thing is your strictly convex. Generally you do not need that strongly convex. So, I just find it, so I just define that way, but generally you need only that convexity and strictly convex. So, you have to remember only these two actually. So, convexity is fine. So, suppose for an example, if you have a function in this way, right. So, what is the definition? See, so this, now suppose this is your x, say this is your y. Now, say this is your t x plus 1 minus t y. Okay. Now, this value is f of y and this value is f of x. Okay. Now, this point will be your f of t x plus 1 minus t y. Okay. And this point will be t of f of x plus 1 minus t of f of y. Now, it says the simple thing. So, whenever you have a domain, in that domain, whenever you join this line will be always, there is always a distance between this and this and this. That means everywhere the curve is actually curve type, it is not flat anywhere. Okay. So, that means it will be your convex. So, this is mean that strictly convex and convex. If it looks somewhere flat at some places, then that will be your only convex, but not strictly convex, but it is always curve type, there is nothing flat, then it will be a strictly convex. Okay. So, it says only this one, that is this value is always bigger than that. Now, for an example, if you take f x equal to x and if you take f x equal to minus x, so they are convex. But not strictly convex. So, you may have function, right, where it is curved, but sometimes after some stage it is little bit flat and then again it gives the curve one, right. You may have this kind of, and then something like so this one and then again this one. So we can have this kind of thing, right. So in that case it will be a convex but not strictly convex, but if you have this kind of thing always curved, nothing flat, then it will be a strictly convex. Okay. Okay, so I have time, so I can move to the next problem. Now look at this one. Now again you face this is a problem from your net question, I think. Now it says that f is a function from again 0 1 to 0 1, it is twice differentiable function and it satisfies this equation. Remember that they are hiding the information that it is convex, and then they are asking this many problems options. So this. Then obviously we know since it is twice differentiable function, so convexity implies this, right. So we know this one. Now what about the others? So can you just remove the other options A, B, C, D? Now for A you can choose f x equal to minus x, right. Now for C you can choose f x equal to x, right, because it is 1, and for D you can choose f x equal to x square. See, if you know the known examples, then you can easily strike out this one. Fine. Okay. So move to the next problem. Again this is also conceptual, so if you do not know, still it will be a conceptual one. Now f x is sin x minus x plus x cube divided by factorial 3 and g x equal to this one, that cos x minus 1 plus x square by factorial 2. Now we have 4 options. So f x bigger equal to 0, for all x bigger than 0, g is increasing function, g is decreasing function, f is decreasing function. So you may have another option that f is increasing function. Now what will be your answer? Yes. Now again you can just use that derivative of this function. So first of all, now this is interesting. So what is my f x? F x is sin x minus x plus x cube by factorial 3, right. Now what is my f dash x then? Just derivative, it will be cos x minus 1 plus x square by 2, right, which is actually g x. So this is a differentiable function, right. Now what is f double dash x? Again it is minus sin x plus x, right, and this is also g dash x. Now if you want, even if you do not know that x bigger equal to sin x, still you can, then you can derivative 3 times. Now that will be 1 minus cos x, which will be g double dash x, and we know that value of cos x is always lies between 1 and minus 1, right. So this is always bigger equal to 0. Okay. Now see that, now from this we know that f of 0 equal to 0, f dash 0 equal to g 0, this is also 0, and here f double dash 0 equal to g dash 0 equal to again 0. Okay. Okay. Sorry. F dash I did not get your question. What? F dash 0? Anyway, I think that is fine. Now, see what is this. So, f triple dash x, that is bigger equal to 0, right. Now, that will imply f double dash x, now this is 0 for all x, right, bigger equal to 0. Therefore, you can say that f double dash x is monotonically increasing function. Right, f double dash x or g dash x, these are monotonically increasing function, right. Now, since they are monotonically increasing, so that's mean f double dash x, which is g dash x, this is bigger equal to, or I can write in this way only. So, f double dash x is bigger equal to f double dash 0, and that is 0, right. So, for all x bigger equal to 0, right. So, that is mean whenever x bigger equal to 0, then f double dash x is bigger equal to 0. So, therefore, again from this we can say that f dash x, which is g x, is increasing function, right. Now, again since this is an increasing function, therefore, f dash x bigger equal to f of 0 bigger equal to, sorry, this is equal to 0, and this is true for all x bigger equal to 0, right. Now, therefore, again f dash x is bigger equal to 0. So, therefore, f x is increasing function. So, step by step you can get all of the increasing function. Now, again this will imply f x bigger equal to f of 0 for all x bigger than 0. Okay. So, we get this is in greater equal to 0, this is increasing function. So, it is not true. Any problem? Yes, no? Okay, fine, right? This is a step by step problem. So, just we have one is greater equal to 0. So, the previous one will be increasing, then again that is bigger equal to 0, again the previous one is increasing, and this is goes in that way. Okay, fine. Yeah.
Sir, I have a problem in problem number 6.
Here in this slide.
No, sir, problem 6.
Where it is? This one. Okay.
Yes, sir. Sir, when f x equal to 0.
F x equal to 0, right.
So then we have to find when both mod cos x and mod sin 2 minus x are 0.
See, first of all, they are both are positive term, right. Now, this is a positive term, this is a positive term, right.
Yes, sir.
So, one cannot be another the negative of others. So, that's mean if f x is suppose 0, that's mean both either at least one in that case. No, you should not say f x equal to 0. So, that's mean if f is differentiable at some point, if and only both should be differentiable at that point. Okay.
Yes, sir.
Now, suppose one of them is not differentiable, then we cannot say that f is differentiable at that point,
Alright.
and one cannot be cancelled out with others, because they are both are positive value.
Yes, sir, I understand.
Okay. So, that is the reason we are considering each of the case separately,
Yes, sir.
because if it I understand your point, if it is suppose minus mod x minus mod x, then that is actually 0, that is a differentiable, right. In that case we cannot say that it is not differentiable because mod x is not differentiable, but here the terms will not be cancelled out because all the terms are positive.
Okay, sir, fine.
Okay. So I was where? Okay, right. So this one was fine. Now this one 14. Now I think you can easily strike out the other one. So now this is a function. Now again you can tell me that one. So f(x) equal to this function. Now which is the following true? So for which value f(x) is differentiable? Not D, because mod x cube it is always differentiable. So the only problem is here. So if a1 is 0, or if and only if you can say this is 0, then we are done. Okay, so this is the only option, this one, since mod x is not differentiable. Okay. Now this is another one. Now it says a, b, c distinct real numbers, and you have this equation. Okay. Now the number of distinct real root of the equation, how many it will be? It depends on ABC. It is 1, 2 or 3. This is a simple one. Problem number 15. Yeah. 3 real root. Okay, so what are the real root? Depends on ABC. ABC. How it can be ABC? It it should not be ABC, right? You should understand the question. So what is the number of distinct real root? Either it will be 1 or 2 or 3. It cannot be all of this, right? Okay. Now see, this is a very simple problem actually. Just take f(x) equal to this one, x minus a cube plus x minus b cube plus x minus c cube. Now what is my f dash x? It will be 3 x minus a whole square, x minus b whole square, x minus c whole square, that is bigger equal to 0. Right? So its derivative is bigger equal to 0, so therefore f is increasing. Okay. Now again the first term is 3x cube, it is a positive term, and so f of infinity, or better to write not f of infinity, I will not write that, write limit x tends to infinity f of x, that is infinity, and limit x tends to minus infinity f of x, that is minus infinity. So you have some strictly increasing functions, kind of that. So it should have at least one, that is exactly one real root, not 2. So this will be the right answer. It does not depends on ABC. ABC can be any value. Okay. Yes, odd degree polynomial always have a real root, that is fine, but here we are not asking that at what is the least, at least. It is saying that what is the exactly number, what is the exact number, 1, 2 or 3, or depending on ABC. Okay. So odd degree polynomial has at least one root, that is fine. Okay, but here we are finding that exact number of roots, not the at least. Okay, we move to the next problem. This. Now you have already solved this one. So mod of f of x minus f of y less than equal to x minus y power beta, where beta is bigger than 0. Then if beta equal to 1, then f is differentiable, f is uniformly continuous if beta bigger than 1, that is a constant, and f is polynomial. B, C. So, obviously, this is not true, right? Why 16 not true? We have taken example f of x equal to mod x, right? So, that is not differentiable, but satisfies this value. And B, we know, we proved that this is also we have seen, right? Now, for D, again we can give this example f x equal to mod of x. You can write also sin x as well. Okay. So, this is very simple. This is also very simple. I expect this from you. That is a very simple one. That is from uniform continuity. Just tell me the answer.
If it's bounded.
Yes. Any other? So, it should be bounded, right? Because we solved that one. F is constant, is it true? No, right? We can just take f x equal to x in real line, but for rational points for B, right? So, this is not true. F is differentiable, again no. We can take f x equal to mod of x minus 1, right? And similarly, D is not true. Okay. Okay, now this is again simple one, just little bit of calculation of is there. Now, first of all, can you see that it is continuous? Oh, continuous or discontinuous?
It's continuous, sir.
Yeah, it is continuous, right? Because if we take limit extends to 0, then it will be 1. So, this. And for any other point, all the derivative exist, we can see. The only problem is when at 0. So, we have to just check that f dash 0 and f double dash 0 exist or not. So, f dash 0 and f double dash 0 exist or not. So, we have to check only these two. Okay. So, just try this one. Okay. And you can find that actually this is true. Oh, sorry. So, it is continuous, right. Okay. Fine. Now, what about this one? Remember that it is written that which of the following are not true. I always miss this point. So, whenever I ask this kind of problem not true, I generally strike out a negative one. Okay. So, first of all, it is given that f is a continuous function from closed interval 0 1 to open interval 0 1. Okay. Now, if f is a closed set, then can we say that f a is a closed set? Yes or no? Yes. Why? Right, right, because the left hand side is compact, right? Because now f is closed, that means here f is compact. You have to remember that f is compact, and since f is compact, so f of f is also compact, because any continuous function sends compact set to compact set and also connected set to connected set. You have to remember that statements, right. So, if this is compact, now since again this is, if this is compact, then it should be closed. So, therefore, it is, that is the statement is true. So, here we are writing not true. Okay. Strike. I always miss that one. The statement is true, but we have to write this is not true. Okay, fine. Okay. Now, what about B? Is that statement true? if f0 less than f1, then this equal to this.
No, sir, it is false.
Right. Now we can just take this kind of one.
It should be the interval infimum of f to supremum of f.
Exactly, exactly. So it may happen that it start from here, right? There is nothing like increasing or decreasing. So it can goes like this, and you can stop at here. So right. So we are it says that the image set range set should be this, but this is not the range set. Range set is actually this one. So this is actually range, right? So this is not true. So we have to write this one. Now what about C? So x belongs to 0, 1, then it has a fixed point. Again, this is true because of fixed point theorem. Because here f is 0, 1, 2, here it is written open 0, 1, right? Now it is subset of closed 0, 1 again. So we can think the function f is from closed 0, 1 to closed 0, 1. So it must have a fixed point. We know that. This is called a fixed point theorem, right? So it must have a fixed point. So we have to cross this one. Now again this is true because this is compact. So image should be, oops, what is that? Oh, right, it is not equal to. So it is negation of negation. Okay. Now obviously it should not be a surjective function, right? Because this is compact. So 0, 1 is compact. Now image of a compact set should be compact, right? But open interval 0, 1 is not compact, so it should be a subset of that. So f of that 0, 1, it should be compact. Therefore, it should be a proper subset of open interval 0, 1. Okay? So the statement is true, so we are striking out this one. Okay? So these are all about for today. So if you have any question, you can ask.